Let's see Jacobson's algorithm, which is used to set the timeout timer. Here in Jacobson's algorithm, it is same as basic algorithm. What was the problem there? We don't know how much should be the round trip time whenever we send the first segment, right? So there we have guessed it. Here also I am going to guess it. So I have written this entire, calculated the entire example. Using this example, I'll explain you the Jacobson's algorithm. Okay, the example starts like this. So initially when I'm sending the packet, I don't know what to expect, which means I don't know when the acknowledgement will come back. Therefore I'm going to guess it. So I'm going to guess that initial round trip time might be 10 milliseconds. That is what I'm going to guess. And along with that, I'm guessing that initial deviation could be 5 milliseconds. What does it mean? I'm expecting that the acknowledgement could come, if I send a segment now, acknowledgement could come in 10 milliseconds. Moreover, I'm expecting that there could be a deviation from this 10 milliseconds. How much? 5. So what is the 5 millisecond deviation is? You take this 10 and you add plus or minus 5, which is nothing but 5 to 15. So instead of expecting that the acknowledgement will come in 10 milliseconds, we are expecting that acknowledgement will come in a range of 5 to 15 milliseconds. So acknowledgement can come anywhere between 5 to 15 milliseconds. Previous case, I just expected that it would come in sometime as a point, but now I am expecting a range. In this range I am expecting the acknowledgement, right? Then instead of putting that in the previous case, basic algorithm, timeout was directly calculated as 2 into round trip time. There was no logic behind that. But then Jacobson, he conducted some experimentation and he came up with a better formula. The formula which Jacobson used is timeout is equal to 4 into deviation plus round trip time, which means whatever is the deviation that you have guessed, that into 4 plus round trip time. Therefore timeout according to Jacobson's algorithm here will be 30 milliseconds. If you had taken that basic algorithm, timeout would have been 2 into 10, 2 into round trip time, which is 20, but here it is 30, right? And what does that mean? Before sending the first packet, just see here, I'll just show you what is happening there. That actually means that when you are sending the first segment, you are expecting that the acknowledgement would come back in 10 milliseconds, and therefore timeout is actually set to be 30 milliseconds. Here you are expecting that you are setting the timeout to be 30 milliseconds. That is what you did, right? So that is what the first initial example is. You are sending a segment and you are setting timeout to be 30 milliseconds according to Jacobson's algorithm. And now what happened is actual round trip time happened to be 20 milliseconds, which means when you have sent out the packet, the acknowledgement came back, it happened to be 20 milliseconds, right? So this is what we assumed. These two are the factors which we assumed, and this is the formula given by Jacobson according to which I calculated this 30 milliseconds. And now this is what has happened, which means when you have sent out the segment, this is what has happened. Therefore, what did you expect? You expected that it would come back in 30 milliseconds, but then it took 20 milliseconds. Therefore, there has been a deviation. Now how much is the deviation? You expected that it would come in 10, but it came in 20. Therefore deviation is 10 milliseconds. What is deviation? Whatever is your initial guess minus actual round trip time, and take a modulus for that. Modulus means without, we are taking the positive value. Deviation is always going to be a positive value, right? So now this is going to be the actual deviation. Now using this, I'm going to guess the round trip time and timeout for the next segment. So this is what I got for the first one. Therefore using that, I am going to guess for the next one. This formula is same as the basic algorithm. Next round trip time is alpha into initial round trip time plus 1 minus alpha into actual round trip time. Assuming that alpha equal to 0.5, that is just an assumption. I am assuming that alpha equal to 0.5, then next RTT is going to be 15 milliseconds, right? And then next deviation is also same formula, alpha into initial deviation. Initial deviation means our initial guess plus 1 minus alpha into actual deviation. Actual deviation means what has actually happened. So depending on those two, I got the next deviation to be 7.5. Now from the first packet, I derived these values for the next packet. Therefore these values are going to be the initial setting for the second packet. So the next for the second segment when you are sending, initial round trip time is nothing but the next RTT from the previous packet. Therefore it is 15 milliseconds, and deviation is also going to be the setting from the previous one. Deviation is going to be 7.5 milliseconds because in the previous next deviation I got it. So now for the second packet, initial round trip time is this and initial deviation is this. Using these two values, I have to find out the timeout, right? So what is the formula? Timeout is 4 into deviation plus round trip time. Therefore I got it to be 45. What does that mean? When you are sending the second segment, you are going to set the timeout to be 40 milliseconds now, right? So just observe this. We expected that the initial one would come back in 10 milliseconds, but it came back in 20, which means it has shown an increase in the time. Therefore we are showing an increase in the timeout. That is how this Jacobson is flexible, dynamic. When the traffic has increased, and acknowledgements are coming late, we are also increasing the timeout timer, right? Now we got timeout to be 45. Oh, it is 45, is it? Timeout is 45 milliseconds. Now this is what we calculated, everything we calculated from the previous packet. This is what has actually happened, which means we expected that the acknowledgement will come back in 15 milliseconds, but acknowledgement came back in 30 milliseconds, which is showing a traffic, right? Heavy traffic. So it came back in 30 milliseconds. Now 30 milliseconds is the actual round trip time. Therefore what is the deviation? From 15 it deviated to 30, therefore deviation is 15. Now using all these values, I will be guessing for the third packet what should be the round trip time and timeout. So I am again using the same formula. Next RTT equal to alpha into initial RTT plus 1 minus alpha into actual RTT. Then what did I get? 22.5 milliseconds. And next deviation is alpha into initial deviation plus 1 minus alpha into actual deviation. Initial deviation is 7.5 and actual deviation is 15. Therefore I got 11.25 milliseconds, right? So these two values are going to be the initial values for the third segment. So whatever I got here, the extra RTT is going to be initial RTT for the third segment. So it is 22.5, and next deviation is going to be initial deviation for the third one, which is 11.25. Therefore timeout is going to be 4 into deviation plus RTT, and I found it out to be 67.5, which means when you are sending the third segment, the timeout has to be 67.5 milliseconds. Now just observe it. It is showing a gradual increase because initially I expected that it would come in 10 milliseconds, but it came in 20 milliseconds. It is showing a increase in the traffic. And then I expected that it would come in 15 milliseconds, but it came in 30 milliseconds. Again it is showing an increase in the traffic. And then I expected that it would come in 22.5, so that is why the next one is 67.5. So as the traffic is increasing, the timeout is going to increase, right? So for the third segment, I am expecting that it would come back in 22.5, but then let us say it came back in 10 milliseconds. So it is actually a decrease, isn't it? For the next packet when you are sending it, you are expecting that the acknowledgement would come back in 22.5 milliseconds, but it came back in 10 milliseconds, which is nothing but decrease in the time, right? So what does that mean? The traffic is less. So what should happen? The timeout timer has to be reduced. Now let's see what has happened. Now you are expecting that it would come in 22.5, but it came in 10. Therefore it is showing a deviation of 12.5 milliseconds. That is actual deviation. Using all these values, you could find out what is the next RTT. What is next RTT? Alpha into initial RTT plus 1 minus alpha into actual RTT. Using these two, I found out that next RTT is this much. And then next deviation is using these two, actual deviation and initial deviation. For the fourth packet, I found out that it is this. Now for the fourth segment, these two are going to be initial RTT and initial deviation. Therefore what will be timeout? Timeout will be 4 into deviation plus RTT. So for the fourth one, when you are sending it out, the timeout is set to be 63.75, which is showing a decrease, right? So watch it, it is increasing, but suddenly it is showing a decrease. It is showing a decrease because the traffic has shown a decrease. The reason is, even though you are expecting that it would come in 22.5, it came very early, which means the traffic might have got decreased. Therefore it is also reflecting in the timeout timer. That is how Jacobsons algorithm is working. What is the main difference between basic algorithm and Jacobsons algorithm is? In basic algorithm, timeout equal to 2 into RTT, but here in Jacobs algorithm timeout is calculated using this formula. Remember this, and all the remaining formulas are same. NRTT equal to, this is same as basic one, and then next deviation is also same as, kind of same as basic one, even though we don't have that deviations in basic algorithm, right? So anyways, Jacobsons is giving better performance compared to that basic algorithm. How did we know that? Using experimentation. Running on a simulator, we found out that Jacobson is giving a better performance compared to basic one, right? So that is all about Jacobson's algorithm. So in exam, what they will give you is, they will give you this initial deviation, initial round trip time, and then they will say that successive RTTs are, so the exam, they might give you some question like this. Questions will on this basic or Jacobson's algorithm will look like this. They will say that initial RTT is, for this question, how do they frame is, initial RTT is 10 milliseconds and initial deviation is 5 milliseconds and alpha is 0.5. They'll give you all this, and then they'll say the successive acknowledgements for the next 3 packets arrived in 20 milliseconds, 30 milliseconds, 10 milliseconds. Then what is the timeout for the 4th packet? 1, 2, 3, 4th. What is the timeout for the 4th packet? They will ask you such a question. So what is it? Initial round trip time they will give you, and initial deviation they will give you, alpha they will give you, and they will say that successive acknowledgements for the next 3 packets arrived in 20 milliseconds, 30 milliseconds and 10 milliseconds. Then what is the timeout for the 4th segment? Then you are supposed to use this method and calculate it. Either they will use you, I'll tell you, they are using this Jacobson's algorithm or basic algorithm, anything, but anyway you have to do it this way, right? Fine, this is all about Jacobson's algorithm. Now there is a basic disadvantage both in basic algorithm as well as the Jacobson's algorithm. The disadvantage is, in order to guess the timeout for the next packet, we are always depending on the previous packets and all the packets actual round trip times, which means in basic algorithm or Jacobson's algorithm, what you are trying to do is, whenever one thing is, initially you are guessing it, right? So whenever you send out the first segment, you are guessing what could be the timeout, initial RTT, and depending on which you are guessing the timeout, right? So if the acknowledgement comes back within this timeout, then it is nothing but the actual round trip time, and you are going to use this one for successive calculations. But there is no guarantee that your acknowledgement will come in within this your initial guess, which means your acknowledgement might get delayed. Then obviously you are going to retransmit, right? So when you are retransmitting for the next time, what should be your initial guess? That is one problem. And second, what I mean to say is, initially you have guessed it like this, but now your acknowledgement is late, therefore there is a timeout. Therefore at this point you are going to retransmit it. When you are retransmitting again, what should be your timeout? That is what I am saying. That is one thing. And the second thing is, let us say either the basic algorithm or Jacobson's algorithm is going on, and you are actually starting, and then it is all working fine, and you are sending the next segment and it is all getting well, and suddenly at some point for some segment, when you have sent out the segment, it didn't come within time. You sent it out but it didn't come within time, right? Then in order to calculate the timeout for the next one, both the timeout for the next segment, when you try to retransmit it, both this basic as well as the Jacobson's algorithm are depending on the actual round trip time. Actual round trip time means it has to come within this time, right? So we are depending on actual round trip time in both the cases, but then we don't know actual round trip time because it is even coming after that, right? So what should be done in this case? Whenever there is a timeout, which means you are sending a segment and you are setting the timeout timer, and the segment's acknowledgement is not coming within that time, then in this case, how should you react? What should be the timeout for the next segment? That is the main thing, right? So for this thing, Karns has suggested a modification. So whenever this happens, either in basic or Jacobson's algorithm, Karns says that whenever any packet times out, for the next one, don't apply either basic or Jacobson's formulas, because anyway you cannot apply it. So you just keep on doubling the timeout timer, which means initially you have sent out a packet with 10 millisecond timeout timer, 10 millisecond and the packet didn't come within time. Then for the next time when you retransmit it, send it with 20 milliseconds. And if the packet doesn't come within this time, again for the next time when you are retransmitting it, send it with 40 milliseconds, right? So that is how he modified it. Until you keep on doubling the timeout timer until at least one of the segments acknowledgement will come in within the time. So once you get it, then that is going to be the actual RTT, and for this one you already know the initial RTT. So from there you can start applying all the formulas, which means from there you think that it is the actual RTT is initial RTT, and then you keep applying the Jacobsons or basic algorithm. That is what Karns has modified. This is called Karns modification to Jacobsons and basic algorithm. Anyway, till now no question has been asked in GATE about the timeout timer calculation, because even though I am specifying all this, many people are not following this, which means many implementations of TCP doesn't really do this. So there has been lot of ambiguity in the terminology, and this kind of question has never been asked in GATE till now. I don't know whether they'll ask it or not, but anyway we covered it. Okay.